One of the core premises of this academic journey is that pretty much all living beings in some way, shape, or form have to make decisions in the present about the future. Bad news here is that humans are not always so good at doing probability. Our intuition does not lead us to the right answer. The famous coin toss problem is exactly one of these examples that shows us that we actually need to slow down a lot of times. So the coin toss problem might go something like this. Which individual sequence is more likely? Heads, 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 or heads, tails, heads, tails, heads? And if you ask just like a random person on the street, they're very frequently inclined to say, oh, the second is more likely than the first, when in fact, each sequence is equally likely. We have 5 coin tosses, and the coin has no memory. It doesn't remember what it did on the first toss or what it did on the second toss. It's a 50-50 chance on every individual toss. And so heads, 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 heads has a 1 in 32 chance of happening, as does heads, tails, heads, tails, heads. Why do we get this problem wrong? Why do we conflate this? Why does our intuition lead us astray? Well, what our intuition does that's partially correct is it reasons as follows. There are lots of sequences out there, and only one of the sequences has all heads. All the other sequences has some combination of heads and tails. And so somehow any sequence that has both heads and tails, especially one that looks pretty evenly matched, about 50-50, seems like it's going to be more likely than an individual sequence that is comprised entirely of heads. It's a great answer to the question, is it more likely that a sequence of 5 coin tosses will have at least one tail, or is it more likely that that same sequence of 5 coin tosses will have 0 tails? Well, sure, it's quite a bit more likely, but that's not the question that was asked. The question was which individual sequence is more likely, and as it turns out, they're the same likelihood. This is just one example that shows us that what we want to do when we're trying to make probabilistic statements, either intuitively or actually writing it down, is we want to slow down and we want to think about the question very carefully.